Good morning, student. I hope you all are fit and fine. I also hope that you have gone through the topic of last class in which I have explained pressure exerted by the fluid, or you can say the liquid pressure, especially I have explained pressure exerted by the liquid and the principle of flotation also. And before that I have also explained about density, relative density and all this. Today I am going to explain about the Archimedes principle and numericals related to these topics. You know children, what is Archimedes principle? What is Archimedes says? Archimedes says that when an object is immersed in a liquid, either wholly or partially, when an object immersed in a liquid, either wholly or partially, the liquid exerts upthrust force on the object which is equal to the weight of the liquid displaced by that object. मतलब जब कोई वस्तु किसी तरल पदार्थ में उसको हम पूरी तरह डुबोए हैं या पार्शियली कुछ पार्ट डुबोए, तो वो तरल पदार्थ जो है उस ऑब्जेक्ट पे ऊपर की ओर बल लगाता है, यानी अपथ्रस्ट फोर्स, बॉयंट फोर्स, एंड दैट बल और फोर्स इज इक्वल टू हाउ मच? किसके बराबर होगा? द अमाउंट ऑफ लिक्विड, या कितने तरल पदार्थ डिस्प्लेस होता है, विस्थापन होता है उस ऑब्जेक्ट के द्वारा, ये कहा गया आर्किमिडीज. I have written on the board also. When an object is wholly or partially immersed in a liquid, it experiences an upthrust or buoyant force which is equal to the weight of the liquid displaced by the object. This is called Archimedes principle. Now, there is an experimental verification also of this Archimedes principle. How you will do the experimental verification, I will explain here. Later on, you will do in the laboratory how to verify the Archimedes principle. First, you note down this principle. Once again, I am repeating. When an object is wholly or partially immersed in a liquid, it experiences an upthrust or buoyant force which is equal to the weight of the liquid displaced by the object. Please write it down. I am focusing the matter of the board. I am giving you a minute to write it down. Now, let us see the experimental verification of Archimedes principle. What you have to do, you take a spring balance, एक स्प्रिंग बैलेंस लीजिए, you take a spring balance and attach an object on it. Now, what will happen? When you will hang the object in the spring balance, you will see, what you will see? The spring of the balance stretches and the pointer comes down somewhere here, यहां कुछ आ जाएगा, इसको हम मान लेते हैं कि W1, that is the weight of the object, weight of the object in air. ये हमने W1 मान दिया. Now what you do, again now you put this whole setup of the spring balance along with the spring balance in this way. You take the overflow can also. Now, when you put this whole setup in the water containing in the overflow can, what will happen? As soon as this object emerges wholly or partially, it will displace some liquid and move to the another beaker lying just below the open mouth of the overflow can. And the initial stage, you see the weight of the object in air was pointing here. It will somewhere, the weight will be shown at the upper end, at this position. This will be W2, means weight of the object in water. Weight of the object in water, W2. Now, why this weight is less than the weight of the object in air? Why? You observe less weight, W2 is less than W1. Why? Because this water, it gives some upthrust force, means force acting in upward direction on this object, due to which the weight of this object, which is immersed in a liquid, partially or wholly, it loses some weight due to this upthrust force. क्योंकि weight of the object जो है नीचे की ओर एक्ट कर रहा, but due to the upthrust force acting by this liquid pushes the object in upward direction, and that's why the reading of the spring balance will be lesser than the reading of the spring balance in the first case in comparison. Now, what will happen? Now, apparent loss in weight of the object will be how much? That will be W1 minus W2, means weight of the object in air minus weight of the object in water. This difference in weight will equal to the whom? This will be equal to the amount of liquid displaced by the object, or you can say that this apparent loss in weight is also equal to whom? Upthrust force. Upthrust force exerted by the liquid on the immersed object. मतलब क्या हो गया कि जो अपथ्रस्ट फोर्स है वो किसके बराबर होगा? अपरेंट लॉस इन वेट के बराबर, और वो किसके बराबर होगा? अमाउंट ऑफ लिक्विड डिस्प्लेस्ड बाय द ऑब्जेक्ट. सो इन दिस वे यू कैन वेरीफाई द Archimedes principle experimentally. We will do the practical also related to this. First we will do the practical with the plain water or tap water. Then in second case we will take the salty water also. So in lab when we will go to the lab, you all will do the experimental verification of Archimedes principle. Now let us see the application of Archimedes principle. Means where this Archimedes principle are applied in our daily life. So first is hydrometer. First application is hydrometer. Hydrometer is based on this Archimedes principle, which is used to measure the density of the liquid. Second application is lactometer. Lactometer is used for what purpose? To determine the purity of the milk. दूध में कितना पानी मिला है उससे आप चेक कर सकते हैं. Next application is construction of ship and submarine. You know the ship, material with which the ship is made up of having higher density than the density of the sea water, but still the ship float on the surface of the sea level. Why and how? It means that the amount of water displaced by the ship is equal to the weight of the ship. जहाज के वेट के बराबर वो शिप जब पानी में उतारते हैं तो वो अपने वेट के बराबर वाटर को डिस्प्लेस करता है. दैट्स व्हाई दिस शिप जो है, दिस शिप फ्लोट्स ऑन द सरफेस ऑफ द सी वाटर. Now you see the submarine, how the submarine works on Archimedes principle. Submarine has a tank having two chambers in it. उसमें दो chambers रहते हैं. When these chambers are filled with air, then what happens? These submarines will easily come up to the surface of the water and they will float on the surface. And when this air is expelled out from this chamber and instead of air, water is filled in this chamber, then what happens? These submarines will sink bottom to the sea level inside the water. So on the basis of this, the submarine works. So these are the few applications of Archimedes principle. Now children, I am going to discuss few numericals related to this topic. I hope you have understood the Archimedes principle, experimental verification as well as application. Archimedes principle, what does it say? When an object is immersed in a liquid wholly or partially, it experiences an upthrust force, and that upthrust force is equal to how much? That is equal to the amount of water displaced by that object, or apparent loss in weight, or upthrust force exerted by the liquid on the object. So now let us see the numerical based on this topic. Now see the first numerical. A plastic bottle of 500 gram has volume of 450 centimeter cube. Will the bottle float or sink in water? Density of water is 1 gram per centimeter cube. Also calculate the mass of water displaced by the bottle. Now first we write down what is given in the problem. Here first it is given that a plastic bottle of 500 gram means mass of the bottle is equal to how much? 500 gram, and volume of the bottle is equal to 450 centimeter cube. What we have to find first? Density of the bottle. Density is equal to mass by volume. Mass is equal to how much? 500. Volume is 450. ठीक है, इसको आप काटिए, 0 0 कैंसिल, 5 9 45, 5 10 50. इसको आप जब डिवाइड करेंगे, व्हाट यू विल गेट? Means you will get how much? 1.11 gram per centimeter cube. इतना डेंसिटी आ रहा बॉटल का. Now, will the bottle will float or sink in water? Now you see in the question, density of water is given how much? 1 gram per centimeter cube, and density of bottle is how much? 1.11 gram per centimeter cube. Which has more density? This bottle. This bottle has more density than whom? Than the density of water. So the bottle will sink. Why? Because its density is greater than to whom? Density of water. ये पहला पार्ट हो गया. ठीक है. इफ यू आर टू राइट इट डाउन, यू कैन राइट इट डाउन. तब उसके बाद सेकेंड पार्ट इसका डील करेंगे. कैलकुलेट द मास ऑफ वाटर डिस्प्लेस्ड बाय द बॉटल. I hope you have written this. Children, you have written it. First part. Now we will move to the second part. Let us see the second part. Now see the second part. Volume of water displaced is equal to how much? 450 centimeter cube, and density of water is equal to how much? 1 gram per centimeter cube. Now mass of water displaced, that will be how much? Volume into density हो जाएगी. Volume of the liquid into density of the water. Volume of the water displaced into density of the water. That will be how much? 450 into 1, that is equal to 450 gram. 450 gram. Mass of the water displaced will be how much? 450 gram. So this is the second part of this numerical. Now children, if you were to write it, you can write it down. Now we will move to the second numerical. I have written it. Now let us see the second numerical. Now see the next numerical. A piece of iron of density 7.8 into 10 to the power 3 kg per meter cube and volume 100 centimeter cube is totally immersed in water. First is calculate the weight of iron piece in air. Second is upthrust force, and third is apparent weight in water. Now let us see one by one all the three parts, calculation of all three parts. First part, what we have to find out, that is the weight of iron piece in air. So first we write here density of iron is given how much? 7.8 into 10 to the power 3 kg per meter cube. Now volume of iron is given how much? 100 centimeter cube. To convert it into meter cube, 100 into 10 to the power minus 6. तो क्या हो जाएगा ये? That will be equal to 10 to the power minus 4 meter cube. Now you know that density is equal to mass by volume. Density is equal to mass by volume. So mass of iron will be how much? अब जानना है density is equal to m by v, तो mass equal to क्या हो जाएगा? d into v. यहां लिखेंगे क्या? Density into volume, that will be the mass of iron. So density is 7.8 into 10 to the power 3 into volume is 10 to the power minus 4. तो यहां कितना हो जाएगा ये? 3 में से वो तो माइनस 1 बचेगा, यानी 7.8 into 10 to the power minus 1, that will be equal to how much? इसको नीचे डिवाइड कर देंगे तो ये जाएगा 0.78 kg. Now what you have to find out? Weight of the iron piece. So weight will be equal to how much? इसमें क्या करेंगे? We have to multiply this with whom? Weight क्या होता है? M into G. Weight of the iron piece M into G. G is क्या है? Acceleration due to gravity. So here we will take, since G is taken as 10 meter per second square, तो यहां वेट क्या हो जाएगा, मास हो गया 0.78 इंटू 10, तो ये अगेन क्या हो जाएगा, ये 7.8 न्यूटन, 7.8 न्यूटन. So then this is the first part. If you want to write it down, you can read, then we will move to the second part of the numerical. I am focusing the matter closely. Now let us see the second part is upthrust force. You have to find out the upthrust force. Upthrust force will be how much? Weight of the water displaced. And how to calculate the weight of the water displaced? That will be equal to volume of water displaced into density of water into acceleration due to gravity. That is, I am taking 10 meter per second G. Now see, so once again, you know that volume of water displaced is how much? 100 centimeter cube. As you have already converted this 100 centimeter cube into meter cube. How? By multiplying it. I am writing in short here. Volume of water is 100 centimeter cube, means 10 to the power 6 से multiply किए, ये हो गया 10 to the power minus 4 meter cube, है ना. Volume of water displaced, तो यहाँ हम लिख देंगे volume of water displaced is 10 to the power minus 4 meter cube into density of water. Density of water is how much? In kilogram, that is 10 to the power 3 या 1000 kg per meter cube. So 10 to the power 3 kg per meter cube and into acceleration due to gravity is how much? 10 meter per second square. ये तो अब क्या हो जाएगा वैल्यू, क्या देखिए 10 to the power minus 4 हो गया ये, और 3 और एक ये है 4, 10 to the power 4, that will be equal to how much? 10 to the power 0, that is equal to 1 Newton. क्या आ जाएगा? 1 Newton. Any numeral value having power 0, the value is 1. So upthrust force is how much? 1 Newton. Now what we have to calculate? Number third part is how much? What is the third part? Children, first to write it down. Number C part. Let us see the number C part is apparent weight in water. Apparent weight of the body in water. For this, what you have to do? You have to do what? Weight of the body or iron piece, whatever the material is, weight of the body in air minus weight of the liquid displaced. Liquid displaced. Now you have calculated in the first case weight of the iron piece in air is how much? 7.8 Newton. And just now you have calculated upthrust force. How much? 1 Newton. उसको माइनस कर दीजिए, you will get 6.8 Newton. This is the apparent weight of the object in water. So children, I hope you have understood the numerical based on the topic Archimedes principle and how to calculate. Please go through this topic. If you have any problem, you can ask your question during the questionnaire period. Till then children, stay at home, be safe, and always focus your interest towards the study. I hope children, we will meet again in the next class. Till then, goodbye. Thank you. Have a nice day, children.